Our lesson today, we want to be able to identify and graph linear functions. Uh, a linear function is a function whose graph is a non-vertical line. A linear function can be written in the form y equals mx plus b, where m is the slope and b is the y-intercept. All of this stuff you guys should be familiar with already. All right, our first example, use the graph to write a linear function that relates y to x. Well, we have the linear function here, and we want to write an equation, right, for that linear function. In order to write the equation, we need our slope and we need our y-intercept. Well, we see the y-intercept is -3, so I already know that b is going to be equal to -3, right? So our b is going to be equal to -3. But let's get rid of this. All right, but we need our slope, so we need our vertical change, we need our horizontal change. Our vertical change goes from 2 to -3, that's a change of 3. Horizontal change is a horizontal change of 2, so 3 over 2. It's positive because it goes up from left to right, so our m is going to be equal to 3 over 2. And that's all we need to write our equation, right? Y equals 3 over 2 times x minus 3, right? That would be that's our graph. And we use the graph to write the linear function. All right, next one. Write a linear function using a table. Well, when we use a table, we still need the slope, we still need the y-intercept. Well, where do we like to start? Well, I like to start here with our y-intercept if it's given to us. And our y-intercept will always be the output when the input is 0. Input are our x values, the output are our y values. So right from the table, I can see that our b is going to be +3. We still need our slope, where our slope is going to be the ratio of the change in y, right? That's down 2, down 2, down 2, over the change in x. And let's see, what's our change in x? +1, +1, +1. So -2 over 1. So that means our m is going to be equal to -2. So our equation is simply y is equal to 2x plus 3. All right. Let's try a couple more on our own. Right. Once again, if we're using the graph, I like to start with our y-intercept. And where does that line cross the y-axis? Well, that line is going to cross the y-axis here. All right. At -1. So our b is going to be equal to -1. Our slope is going to be our vertical change, and our horizontal change, our rise over run. Our rise is 1, our run is 2, and that is negative because it's going down from left to right. So our m is going to be -1 over 2. So the equation for this function would be y is equal to -1/2 x minus 1. This next example here, I can see my output when my input is 0. Right? My output is 2 when my input is 0, so that means my y-intercept is going to be 2. But we still need to find our slope. So let's see, what's our slope? Well, we have a change of 0 here. Change of 0. Change of 0. And this is what? That's an increase of 1. Increase of 1. Increase of 1. So our m is 0 over 1, which means we have a slope of 0. And what do we know about a slope of 0? Slope of 0 is going to be a horizontal line. So the equation is going to be y is equal to, well, instead of writing 0, x plus 2, right, we know that 0 times x is 0. So the equation of this line would simply be the horizontal line that crosses the y-axis at 2. And the equation for that line is y is equal to 2. All right, let's see what we have here. You're controlling an unmanned aerial vehicle, for surveillance. The table shows the height y in thousands of feet of the UAV, x minutes after you start its descent from cruising altitude. Write a linear function that relates y to x. Interpret your slope. Interpret the y-intercept. Well, here's my b. My output when my input is 0 is 65, so we know b is going to be equal to 65. We still need our m. RM is going to be the change in Y over the change in X, that ratio. So it looks like it's down 5, right? Down 5, down 5. This is what? An increase of 10, plus 10, plus 10, right? Plus 10. So negative 5 over 10, that simplifies to negative 1/2. So the equation of that line would be Y is equal to negative 1/2 X plus 65. Now, the question asks us to interpret the slope in the y-intercept. Well, let's start with the y-intercept. Right? The problem says that it's going to descend from its cruising altitude. So that 65 represents its cruising altitude. Right? Cruising, right, altitude. Right? Altitude. And then the negative 1/2 X represents the drop in feet. And what would that be? Every minute. So that negative 1/2 X, right, is the decrease in altitude, right? The decrease in altitude each minute, each minute, each minute. All right. What else we got here? Okay, and here, same problem, right? We have our equation, right? We have the decrease in altitude over the course of a number of minutes. And then let's see, plot the points in the table and draw the line through the points, right? If we're graphing the linear function, that we know. Because the time cannot be negative in this context, use only positive values for x, all right? We're good with that. Find the height when x is equal to 60. Well, let's see, that would be right about here. And if we were to estimate that, that looks like it's in between, what, 30 and 40 feet? So I'm going to say that's 35 feet, all right, if we're using the graph. But let's use mathematics to be sure, right? So if we're using mathematics, let's be sure with that. So we have y is going to be equal to negative 0.5 x plus 65. I'm going to replace x with 60. So y is equal to negative 0.5 times 60 plus 65. Negative 0.5 times 60, that's going to be negative 30. So y equals negative 30 plus 65. Right? So the math confirms, right, that the altitude would be 35 feet, right, after 60 minutes or 1 hour. And we can kind of see that looking at our graph here. And we also are able to confirm that with our mathematics. All right. Now here we're asked to compare linear functions. The earnings y in dollars of a nighttime employee working x hours are represented by the linear function. Y is equal to 7.5x plus 30. The table shows the earning of the daytime employee. All right, here's the daytime employee. Right. Well, if we look at the rate of change, right, the nighttime employee has a rate of change of 7.5. Right? And the daytime employee has a rate of change of what? Right? Looks like that's 12.50, right? Every hour. Right? For every hour. So if which employee has a higher hourly wage? If we're just talking hourly wage now, the nighttime employee has $7.50 hourly wage. $7.50 for every 1 hour. The daytime employee has a $12.50 wage for every 1 hour. All right. Write a linear function that relates daytime employees' earnings to the number of hours worked. In the same coordinate plane, graph the linear functions that represent the earnings of the two employees and interpret the graph. Well, the daytime employee equation would be y is equal to 12.5x, right? Right, 12, let's undo that. Right, y equals 12.5x. That's the daytime employees. So here's the graph of the daytime employee, nighttime employee, and we're asked to interpret the graphs. Well, we see that initially the nighttime employee starts out more, right? Because with 0 hours, the nighttime employee has that $30 that he starts with, or she, and the daytime employee starts out at 0. But as we continue, right, hour after hour, we get to this point here. And at this point, we see that the daytime and the nighttime hours, right, hourly employee, make the same amount of money. And then all of a sudden the lines cross. So after 6 hours, the nighttime employee makes less after 6 hours, and that will continue forever. The daytime employee after 6 hours will make more than the nighttime employee. Right? So that 6 hour line is really, really important because it shows when the daytime and nighttime hourly employee make the same amount of money for a given number of hours, and then afterwards who makes more. All right, let's finish this up here. Manager A receives a $15 per hour and receives a $15 bonus. The graph shows the earnings of Manager B. All right, here's the graph for Manager B. Which manager has a higher hourly wage? Well, $15 per hour here. What are we making here per hour? Well, we have 1 and 25, 2 and 50, 3 and 75. So that seems to be $25 per hour. So Manager B is at $25 an hour. Manager A is at $15 an hour. So which manager has a higher hourly wage? Right, Manager B. Right, Manager B. Right, because 25 is greater than 15. After how many hours does Manager B earn more money than Manager A? Well, that's a different question. All right, so let's make a little table of values here, and let's try this for 1, 2, 3, 4, 5, 6, 7. Let's see if 7 hours is enough. This will be our input. We have 15x plus 50, and our output's going to be y. All right, because the equation here would be y is equal to $15 an hour plus the $50 bonus. So we have 15 times 1 plus 50, that's what, 65. This is going to be 15 times 2 plus 50, that's going to be 30 plus 50 is 80. 15 times 3 plus 50, that's going to be 95. 15 times 4 plus 50, that's going to be 15, 30, 60, 110. This is 15 times 5 plus 50, that's 125. 15 times 6 plus 50, that's going to be 140. And then 15 times 7 plus 50, that's going to be 100, what's that, 55, 20, 30, 40, that should be right. Okay, now let's see. If we're looking at the other table here, we have, if we graph those points, let's graph them because that'll help us see the line. 1 in 65, that's going to be 50, 60, 65 is going to be about here. 2 and 80, here's 2. 80 is going to be just above 75. 3 and 95, 95 is going to be a little bit less than 100. Then we have 4 and 110. Here's 4. 110 is going to be a little bit above. 5 and 125, that's where they are the same. And then 6 and 140, here's 6 and 140. That's going to be a little bit less up here. All right, so I think we found the point at which, right, one is going to be more than the other, right? But we have to be careful when we draw our line because we want to start at that 50, right? Start at the 50 and we go through there. So I think that'll work. All right, so after how many hours does Manager B make more money? What did we say? It looks like at that 5 hour mark, right? We see that here. So after 5 hours. After 5 hours. All right, so I hope that lesson was helpful when we want to represent linear functions using tables, using graphs, using equations, and we'll see you soon.